Welcome to part 4 of the Python course. This section covers sequences in Python and details the three types of sequences available: lists, tuples, and strings. We've already had a brief look at this type of structure because a string is an example of a sequence. But there are two other types of sequences we're going to deal with as well. And a sequence is a very, very important part of the data structures in Python. There are quite a few sequences, but the three we are going to deal with are strings, something called lists, and finally a sequence called a tuple. The first type, as I said, is going to be strings. We're going to have a look at lists, and lastly we're going to have a look at tuples. Now, what is a sequence? Well, it's basically a series of characters or values that are contained inside a named structure. That means that all these values are given exactly the same name, and we can then access those values using a specific thing called an index number. So for example, if I create a string, I'm going to call it string, and I create that string as being the word Python rocks. What I've just done is I have created a sequence. The name of the sequence is string. You can call it anything you like. And the contents inside that sequence are the characters Python space rocks exclamation. So that is the contents of that particular string. Now, all sequences in Python can be indexed. So all sequences can be indexed, and in Python, indexing starts at 0. I'll show you just now, but negative indexing can also be used. Right, so let's now have a look at how we can work with this particular string. I created a string that said Python rocks. So now if I start and I say print string, and I want to print out the first letter inside that string, I'm going to use an index number. Now the index number for that first character is 0 because index numbers start at 0. So any sequence will start with an index number of 0, 1, 2, 3, and so on. To enter an index number, we use brackets. So we open our brackets and I put a value of 0 in there as the index number. And when I run that, it then goes to that string. Index number 0 is the capital P, and that is what it extracts. So we're using the print statement just to print out that value of P. If I now type out string -1, -1, as I told you, negative indexing can also be used, and -1 points to the last character inside a sequence. So if I run that now, it extracts the exclamation mark. So -1 will be the last character, -2 would be the S, -3 would be the K, and so on. If I had to change this to -3, we can see now it displays a K. All right, so negative indexing basically starts counting from the end of a sequence. So positive indexing will count from the start of a sequence negative indexing from the end of a sequence, and it counts backwards. Right, so just to give you another example, if I say print string index number 7, it comes up with R. Why? Because R is index number 7. You've got 0, 1, 2, 3, 4, 5. The space is index number 6. So R is index number 7. So please remember that spaces are a valid character in any sequence. Now that we've had a look at how to index a value using these brackets, I'm going to talk about something called slicing. Now, slicing is a way of indexing something using these index numbers, but we can now get a range of index numbers. And for slicing, we start off with a start point. We then have an end point, and finally a step size. So we have a start, an end, and a step size. You'll notice that this is very similar to the values we used in the range function. All values will be extracted from any sequence starting at the start index number, ending at 1 less than the end index number with the step size you've specified. So if I had to do this, print string 0 to 6, it's going to print out the word Python. Why? Starts off with 0 and it extracts characters 0, 1, 2, 3, 4, and 5, which are the first 6 characters in that sequence. So we end up with the word Python being displayed. If I say print string, let's go 7 to 12, we now end up with the word rocks, because remember 7 is R. So we've got 7, 8, 9, 10, and 11. So that is what it extracts from that particular sequence, the word rocks. If I do something a little bit ridiculous, let's just have a look. If I say I want you to start at 0, go up to 13 with a step size now of 2, we end up with every second character being extracted. So we end up with PTO and then OK. All right, so that is incrementing that step size. One very important thing, leaving out values will forces Python use the minimum and maximum index numbers. Right, so what do we mean by that? If I do the following, if I say print string, and then inside brackets I say :6 : I have now not specified a starting value. You can see there it's blank. And I have not specified an increment. So what Python will do is it will only use this end value. The starting value will be taken as 0, and the increment will be taken as the default value of 1. And we end up with the word Python displayed. If I say print string, and I say, I'm not going to specify the starting point, I'll leave it blank. I'm not going to specify the end point, I'm going to leave it blank as well. So now it's telling Python, I want you to run through the whole sequence. But I want you to do it with the step size of -1. What Python does is it says, no problem. and it displays that string backwards because it starts at the end, runs all the way to the beginning, decrementing the increment by 1 each time. The index number decreases by 1. So we end up with a string being read backwards. All right, so indexing is actually quite simple, but it's something you need to practice. So please go ahead and practice it as much as possible. We are going to be using it a lot for the remainder of this course. Right, what we're going to move on to now is the second type of sequence, which is the one known as a list. Now, a list is again a sequence. Those of you who have done any type of programming previously, words for a sequence can be an array or a vector, for example. And this can contain any data type. Something very important in terms of a list is that all values in the list are comma delimited. That means that each value, if you print out that list, each value is separated by a comma. When you create a list, you do exactly the same. You separate each value in your list using a comma. To create a list, we use brackets. Brackets, we all know what brackets are. It's these things. Whoops. Are used to create a list. So let's put together a first list to see how they actually behave. I'm going to create a list. I'm going to call it ints for integers. Remember, a list uses brackets to create it, and we can start off with giving it some values. All right. So what I've done is I've created a list. That list is called ints, and it has 8 integer values inside. You'll notice that each value is separated by a comma. Create another list. I'll call it list 1. Start off with 1, 2. We can give it a floating value. And finally, I'm going to give it a string. All right. Python doesn't mind what data goes into a sequence or a list. A list can contain any other type of data that we've already covered. It can contain floats, it can contain integers, it can contain strings, and you can even put another list inside a value for a list. So I could say list 2, for example, is equal to 1, 2.56, and I can say it's also equal to 3 and 12. So what I've done now is I've created a list which contains another list at position, what's that? Index position 2. So if I had to do this, I'm going to run that code. If I say print list 2, index number 1, we are going to get 2.56. There it is there. So in index position 1 of that list, we've got the value 2.56. If I, however, ask it to print the value at position 2, in other words, index position 2 of that list, it comes back and it says it's another list containing 2 values, 3 and 12. So lists are incredibly powerful because you can contain any other type of data inside a list. You want to extract that value there, the 12, from the list that's inside another list. we need to use the index number for the second list. So what we would have to do, again, we've got a list here and that has index number 0 and index number 1. So what we would do then is we would say print list 2. This complete structure is at position 2. All right, so it's that complete structure is index number 2. And then we want to extract the second value. This value is index 0 and that is index 1. So again, here we open up another index bracket and we put index 1 in there. So if I run that, it will extract 12, which is that value there. Okay, so you can extract whichever data you want. You can have the complete item taken out using index 2, or you can specify an index number inside that internal list as well. Okay, let's put together an example that we can actually work on, a real world example. So I'm going to create a list. I'm going to call it marks. And let's say the first mark will be for maths. Let's give it a value. Let's make it a nice high mark. Go for English. English, not so good. And finally, let's choose physics. We'll put a mark of 65. Okay, so all I'm doing is creating a sequence. It's a list called marks, and I've given that list certain data. You can see that 3 of the items are strings and the other 3 items are integer marks. So now, if I want to access the list, I can say print marks 5, and it will come back with the value 65, because that is the mark for physics. That is index number 5. I can extract lots of data in the same list by saying print marks 4 equals marks 5, and let's add a percentage sign to it as well. So what is going to happen now? This is going to get various values from that list. The first time it's going to look at index number 4, so it's going to extract that. It's then going to add an equal sign to it. It's then going to look at marks 5. It's going to extract that, and it's going to hopefully add a percent sign to it. So when I run that one line of code, it's going to come back and say physics equals 65%. So what it's done is it's extracted the required values from one particular list. Okay, so working with lists, it's very, very simple as long as you understand how the indexing works. And that's what you need to go and practice. We can create new lists by using the slicing method that we dealt with earlier. Previously, I created a list called ints, which contained values. Let's just give it a whole lot of values. Messed up there. Right, from 1 till 9. Now, if I want to create a list containing odd values, I can say odd equals ints, and then I can produce some slicing. I'll say I want you to start at the beginning, run all the way through to the end, and take out every second value. And if I now print the new list called odd, you can see that what it's done, it's created a new sequence. It's a new list. It's given it a new name, and that list contains data from another list. The data has been extracted from that list, by using slicing. We didn't specify the first value, so we're starting in the beginning. We didn't specify the end value, so we're running all the way to the end, and we are telling it to take out every second value. So it starts off with 1, then 3, 5, 7, and 9, and that is exactly what we get in that new list that we've created. Now, any value inside a list is not constant. There is a word for that. It means that a list is mutable. So values inside a list can be changed. The word mutable is very important. We just highlight it because it is important. So for example, I created a marks list up here, maths, English, and physics. And let's say I wanted to change one of the marks. Instead of 65% for physics, let's say a mistake was made and the person got 68%. I can quite easily do that by saying, let me just take the whole thing so that we can access it. I can say marks. Now, what value is 65? It's marks 5. And I can now give it a new value of 68. So if I enter that, I have now updated the marks list. So that value there is hopefully being changed. And if I now print out all the marks, we can see now that that mark for physics has changed from 65 and it has now been changed to 68. So we can update any value inside a list simply by using the equal sign. We can also add a new entry to that list. I can say marks plus equals, and I can give it a new value. I can give it a value for LO. What's that? Life orientation is normally a ridiculously high value, so let's give it 75. And I can run that. And now if I print out the whole marks list, we can see now that we've added a new value to it. There is LO, and there is the mark for LO. What does this symbol do? We dealt with it previously. It's called concatenate. So we have concatenated a new set of values into an existing list called marks. And all we've done is it gets added on to the end of that list. Now, there are various methods that we can use on lists. So I'm going to show you some of these methods now because they are reasonably important. So let's move on down to methods on lists. Methods are quite important, and it allows us to work with lists to do specific functions on lists. And the first one I'm going to look at is something called append. What append does is it adds a value to a list. It always adds it to the end of a list. So let's create a list. I'm going to call it ints, and I'm going to say ints is equal to 1, 2, 3, 4, 5. Just like that. Okay, so we've created a simple list called ints, and it has 5 values. So if I say print ints, it's going to print out 1, 2, 3, 4, 5. If I now want to add a value, if I say ints dot append, we can now give it a value, and I'm going to say I want you to add a value of 7 to that list. If I print out that new list, we now have a value of 7 that has been added or appended to the original list. Remember, the append function or method always adds in the number to the end of the existing list. So this is important because if I add in another value, if I say int.append and I give it a value of 6 and then print out ints, what happens is we can see 1, 2, 3, 4, 5, 7, 6. Okay, so those values are not automatically sorted. They will be placed in the position where they were originally placed. Right, so let's see how we can use this. I'm going to start off with an empty list and I'm going to call it ints. So what I've done by doing that is I've created a list which contains no values. This is valid in Python. We can do that quite easily just using the following code. So with ints, I've created an empty list and now I'm going to use the for iteration. So I'm going to say for I in range, let's start off with 1 and go up to 16. And I'm going to say ints dot append I. So there it is. So if I run that code, I have now created a list which is empty and I have now filled that list, because if I print it, we can see that we have a list containing all the values starting at 1 and going up to 15, 1 less than the endpoint, because this line of code is now creating the values in the list. It's adding each value into the list called ints using the append method. All right, so it's a quick and easy way of creating a specific list. Okay, well, you can add more values to it if you change the endpoint here. If you made this 20 or 61, for example, if I run that now, we can see we have a list starting at 0 and going all the way up to 60. Okay, so that's one way of creating a bigger list. If I go back to the original list, which was 16, I can then also create a new function for I in range, and I can start at 16 and go up to 31, and I can then use ints.append I. So what that will do now is add some more values to the existing list. So if I print out ints, we can see that it's taken that list that we created using that code and it's added some more values to the end of the list. So instead of stopping at 15, the list now carries on from 16 all the way up to 30. Okay, so adding values to an existing list is quite simple. You just use exactly the same code, which is the append method. So I'm going to create another quick little list. I'm going to call it characters, and I'm going to give it, start off with A, C, E, and let's go for a D. So there I've got a list which is containing 4 letters A, C, B, D, and you can see that they're not in order. So now I want to show you that there is a specific method called sort. So if I type characters.sort, just like that, and run it, and then print out the list called characters, what it's done is it's sorted that list. So now it's got A, B, C, D. So it sorts it alphabetically. The sort also works on numbers. Okay, so the sort method works alphabetically on characters, or it will sort numbers in numerical order as well. So the sort function is actually quite useful for doing that. There is another function called reverse. So if I say characters dot reverse and then print out characters, we can see that we've got the original list, but now displayed in reverse order, D, C, B, and A. Okay, so reverse will simply change the order of a specific list. Remove is another function. If I say, characters dot remove, and I tell it to remove the letter B, if I print it out, print characters, we can see now the list no longer contains the letter B because we've removed it. Again, remove also works on numbers. Okay, so those methods are quite useful for working with lists. There are a couple functions that also work on lists, which are quite handy. We've got a list up here called ints, which starts at 0 and goes up to 30, and we can use these specific functions on the list. So I can say print the minimum value of ints, and it will come back and say the minimum value is 0. Max also works. So if I say print max on ints, it comes back and tells me that the maximum value is 30, which is correct. So the minimum value is 0 and the maximum value of that list is 30. So min and max works quite well. We can also get sum. So the sum totals all the values inside the list. So if I say print sum ints, it comes back and says, right, the sum is 465. So all the values in that list total 465. And lastly, we can say print length of ints, and it will come back and tell me that there are 31 values inside the list, which is correct. It starts at 0 and goes up to 30. So there are 31 values. These 4 functions are very important working with lists, and we can use these functions quite well to do other calculations on a list. So for example, if I wanted to calculate the average of that list, I can say the average is equal to the divided by. So the sum is the average is 15. So it's taken the sum, which is 465, and divided by the length, which is 31, to give a value of 15. Thank you for watching. If you enjoyed this video, please don't forget to subscribe to the channel for more like it.